All right, good afternoon. The first test will be made available on Friday and will be due by Monday night. And looking at resuming what we have been looking into from the start, and we have among our review items, okay, we have just going back to multiplying polynomial expressions, and we have on page 113. So we have a couple of binomials, and both of these happen to be presented with the letters W and Y. And if we look at attaining the product, okay, of multiplying 5w cubed plus 6y squared by 2w cubed minus y squared, again, you can take any version of the FOIL method. Okay, you could take either the box method or what they might also refer to as the geometric FOIL approach, or you can go with just the regular pathway. And now for the first product, okay, we have the leading terms from each binomial to be 5w cubed and 2w cubed. And if I multiply these two terms together, so I have 5 times 2 is 10. And we have w cubed times w cubed, so this would be w to the 6th. Okay, so 10w to the 6th is the first product. Now for the outside terms, I'm connecting 5w cubed with the negative of y squared. So this product is going to be minus 5w cubed, y to the 2nd. And for the inside product, okay, so I'm connecting 6y squared and 2w cubed. And so we're going to have a positive product, okay, whereupon we have plus 12. And we have w to the 3rd, y squared. And for the last product, okay, we have 6y squared times the negative of y squared. So we have negative 6 times y to the 4th. And in the follow through, okay, now we have two like terms with the outside and the inside products. So joining those together, we come out to 10w to the 6th, and what is going to be plus 7 w to the 3rd, y squared. And we have minus 6 y to the 4th. And that will be the final answer for this leadoff problem. Now, in the case of what we have with the next item, okay, we have for number 34, and this time we're going from two variables to where we have working with the single variable t, and we have almost the exact same terms, but the binomials will have the opposite operations. One which we have in subtraction with 9t minus 4, and the other we have with addition with 9t plus 4. And again, if you have almost the same terms, but you have plus for one set and minus for the other, okay, we're going to have a difference of squares as the result. So for 9t times 9t, okay, we come out to 81t squared. And the outside and the inside products will end up becoming additive inverses of each other. So connecting 9t with 4, okay, so you have a positive 36t. And connecting negative 4 with 9t, we have minus 36t. And the last product, we have negative 4 times 4, so we have a minus 16. And again, so we have the outside and the inside products to cancel. And the resulting difference of squares we will have with 81t squared minus 16. And then shifting gears, okay, instead of multiplying binomials, we're now looking at factoring. And in the case of 46, okay, this is where we have again working with an expression in t, and we're looking at factoring 12t squared minus t minus 6. and this trinomial can be factored. Okay, and creating a pathway to solving. Okay, so if we look at factoring by grouping, okay, we can take the first and the last coefficients of the trinomial. Okay, so we have 12 times negative 6, and 12 times negative 6. Okay, we have negative 72. Now, we're going to be looking for factors of negative 72 that will add up to negative 1, which is the coefficient of the middle term. And so for what we have, and looking for factors of negative 72, and trying to find those that will add up to negative 1. And once again, we got to negative 72 with 12 and negative 6. Now, the numbers do multiply out to negative 72, but if you were to add together, okay, we would have the sum to be positive 6, but I want negative 1. And so for negative 72, there will be more weight given with the negative factor than what we have in the positive. In this case, we're going to have negative 9 and 8. Negative 9 times 8 is negative 72. Negative 9 plus 8 is negative 1. So this will be the combination that we're looking for. And so looking at splitting up the middle term in this trinomial, so with negative 9 and 8, we can form a couple of t terms. And even though it really doesn't matter what order you place these, I'd rather, if the coefficients are such that we have one to be negative and the other positive, I'd rather have the positive to be following. Okay, and that is to ensure that the middle operation is going to be addition. So by the time I quantify the pairings in parentheses, I'm not going to have to perform any sign changes once I put the last two terms in parentheses. So for what we have in the mix, okay, so you have 12t squared minus 9t, then we have followed by plus 8t minus 6. And looking at grouping into pairs. So the first two terms, again, we have 12t squared minus 9 times t. Again, we have with the middle operation, okay, so we have addition and we have of 8t minus 6. And so looking at drawing out, okay, the greatest common factors, we have with 12t squared minus 9t, okay, both of these terms have the letter t, and the highest number that will go into 12 and negative 9 will be 3. So we're going to have the greatest common factor will be 3t, and taking this into 12t squared minus 9t, so we have 4t minus 3, and bringing down the addition. And we have with 8t minus 6, okay, so we have t only present in the first term in this pair, so the greatest common factor is only going to be limited to a number. So it'll be the highest value that will go into both 8 and negative 6, and so that will only be 2. And taking 2 into the second group, we also come out to 4t minus 3. And so we have for the end result here, we're going to have the binomial that is shared between the groups with 4t minus 3. And we have the other factor will be the greatest common factors and the linking operation between the pairs, which we had to be addition. So we end up with 3t plus 2. Okay. And that will be the final result in this case. And you can always go back and check. So again, we have 4t times 3t, you have 12t squared. And again, you have the outside product in this case, which will be 8t, and then inside product we have negative 9t. And so that goes back to negative t, and negative 3 times 2 comes out to negative 6. Right. And now I just wanted to mention, okay, so 12t squared minus t minus 6, we could go ahead and factor into trinomials. And again, the path forward was through factoring by grouping. Now, for what we have in the next case, and this will also involve factoring by grouping, okay, but there's going to be an added precautionary step, so to speak, and that is where you're going to have greatest common factor outside of that which you would obtain from the factoring by grouping. And for what we have in 47, okay, so we have 8x cubed minus 40x squared y and we have plus 50xy squared. And if you notice, okay, we have even numbered coefficients throughout with 8, negative 40, and 50. And also common to all three terms, we have the letter x. Now, we have x in common, and the highest number that will go completely into all of 8, negative 40, and 50. Okay, that is going to be the number 2. And so we have, for the greatest common factor, okay, we have the numerical factor, we have it 2, and again we have x in common, so the greatest common factor will be at 2x. And so in looking at starting off in the case of factoring, so we have 2x and into our original trinomial, so we have 4x squared and 2x into negative 40, x squared y. So 2 into negative 40 is negative 20. Now for x into x squared, there's still a degree in x left over. And you have y to be brought down. And we have for the last two, we'll go into 50 25 times. And we already have the x present, so x into itself is 1. But from 50 xy squared, you still have the y squared to be brought down. And so right now we have 2x factored out. And now we have with the trinomial that is left over, okay, we're going to have this to be factored out. And for 4x squared minus 20xy plus 25y squared. Okay, now this trinomial can be factored because we have not only the right coefficients, but we also have the right degrees throughout. And if you notice, okay, you're looking at almost like a twofold quadratic and form situation. Again, an equation that is quadratic in form will be where in the variable, okay, you're going to have the lower degree variable to be half the degree of the higher. And if you notice, we have x squared in the middle term. Okay, you have the lower order. In x term, you have x to the first, and guess what? Simultaneously, you have y squared at the end, and you have the other variable term is half the degree in y. So you have this term to be half the degree of what we have from the x squared is also, and also from what we have in the y squared. And looking at what we have here, crossing over into the realm of factoring by grouping. So if I multiply out the first and the last coefficients, so I have 4 times 25, okay, that is equal to 100. And for what we have in the case of factors of 100, and I want the sum of the factors to be negative 20. once again, we started out with 4 and 25. Okay, those numbers add up to 29. Okay, but to get the right combination that will add up to negative 20, it turns out that we're going to have the factors to be identical with negative 10 and itself. Negative 10 times negative 10 is 100. Negative 10 plus negative 10 is going to be negative 20. So upon taking what we have with the trinomial, so I'm going to split up the negative 20xy and so we'll have upon splitting up so we're going to have 4x squared and we have minus 10xy. We have another negative 10xy. Now this particular situation where we have the middle operation to be subtraction, that particular part was unavoidable because we have both coefficient factors to be negative. Now once we look into factoring by grouping, okay, so we have 4x squared minus 10xy. Now after the first group, now we have the operation in the middle is subtraction. Now this we had to be careful. If the middle operation is subtraction, you're thinking of quantifying the last two terms in parentheses while conceptually factoring out negative 1. So minus 10xy is going to be the opposite sign of 10xy. And 25y squared, that's going to be like the opposite sign of negative 25y squared. And for what we have in following through, so with the first two terms, okay, we have x in common and even coefficients. So the greatest common factor, we're going to have 2x. And we have times the quantity of 2x minus 5y. And bringing down the subtraction, now we have y in common to these last two terms. Highest number divisible into 10 and negative 25. Okay, that's going to be 5. So greatest common factor here is going to be 5y. And into the last two terms. So we have 2x minus 5y. And so for what we have, we got 2x minus 5y, which is shared, and then combining the outside terms from the greatest common factors as well as the linking operation, we're going to end up with another 2x minus 5y. And again, this particular binomial repeats, and so we're going to have condensing to 2x minus 5y raised to the second. Okay, so going back to the original problem, okay, so we worked quite a bit with the trinomial, okay, and again, just going back to our problem, okay, so we have it's easy to get kind of lost in the forest, especially with all the stuff to go through in this section. But again, we started out with the greatest common factor at 2x, and for the rest of the solution, okay, we have times the quantity of 2x minus 5y raised to the second. And that'll be the final result here. All right. And now, I don't think that in your test, okay, you're going to have to factor sums or differences of cubes. But for what we have in the case of this upcoming problem, okay, there's a bit of multi-factoring. For 54, okay, now we got with the variable m. Now we're not solving an equation, we're just looking at factoring. Here we have m to the 6th plus 9m cubed plus 8. Now, if you notice, okay, just like equations, quadratic in form, again, where you have a 2-to-1 ratio between the higher degree in the variable and the degree of the lower order term. Here we have 6th degree in m, and here we have 3rd degree in m, so you have a 6-to-3 or a 2-to-1 ratio in m. And the coefficients are lined up so that I'm able to factor. Now for m to the 6th, I can factor this in terms of what the expression is quadratic in. So in this case, that is going to be m cubed. So m to the 6th goes to m cubed times m cubed. And for 8, factors of 8, that will add up to 9. Okay, so we have plus 8. And also a plus 1. And just taking what we have. Now, again, I don't think we'll be looking at factoring sums or differences of cubes. Okay, but just sort of restate. When we looked momentarily, say, into sums of cubes, like I have like a cubed plus b cubed. Now, you have a 2-term expression factor, which was originating from the addition. So you have the first order factor. We're looking at taking the sum of the cubic roots of a to the 3rd and b to the 3rd. So that was a plus b. Now the trinomial factor, okay, this would be a squared minus ab plus b squared. And looking at what we have with m to the 3rd plus 8. Okay, so with m to the 3rd plus 8, now we already have m to the 3rd to be the cube of m, and 8, okay, that is a perfect cube, and that is going to be the cube of 2. So for m to the 3rd plus 8, we have m to the 3rd plus 2 to the 3rd. So you can envision a as being represented by m and b represented by 2. So we have with a plus b, we're going to have m plus 2. And for a squared minus ab plus b squared, so we have a squared is going to be represented by m squared minus ab, okay, we have minus m times 2, so we have a negative 2m, and plus b squared, okay, that would be like plus 2 squared, which is going to be 4. And we have with m cubed plus 1. Okay, so your a is going to be m, and your b is going to be at 1. You have like m to the 3rd plus 1 to the 3rd. And the a plus b, we have m plus 1. And for a squared, okay, so you have m to the 2nd, and we have minus m times 1, so this would be a negative m. And we have plus b squared, in this case 1 squared, which is going to be 1. And so looking at what we have overall, okay, so we have with the factors, okay, so you have m cubed plus 8, so you have m plus 2, again we have m squared minus 2m plus 4, and as for m cubed plus 1, okay, so you have m plus 1, we have times the quantity of m squared minus m plus 1. And Now, so I would double check, but I'm quite sure you will not have sums or differences of cubes in your exam. Okay. All right. Now, in looking at what we have in the crossover, okay, to rational expressions, and again, I believe when we first looked into them, there was the little part about restricted values, and that particular topic, that's going to be recycled somewhat when we get into functions and then crossing over to what we refer to as rational functions. And we have in the case of 61, now we're looking at simplifying the ratio and then identifying what the restricted values will be. In other words, like what m cannot be equal to. And here we have with the expressions, so we have m squared minus m minus 12. And if I were to simplify this expression, okay, so we have with m squared minus 16. Okay, so I have a difference of squares. So I have m plus 4 times m minus 4. And for m squared minus m minus 12, we have in factoring. Okay, so we have, that's going to be m minus 4 times m plus 3. And if you notice, we have between the numerator and denominator, there exists a common factor with m minus 4. And for the simplified result, okay, this will come out to m plus 4 all over m plus 3. Okay. That's the simplified result, but those are not the same statements. Okay, in other words, kind of like drawing a parallel. You might have a 6 foot tall dad who has a 3 foot tall toddler. And so in terms of their respective heights, the dad's height to the kid's height is like 6 to 3, which goes to 2 to 1. But still, it's like in the original setting, the dad is 6 feet tall, the kid is 3 feet tall. And to say that dad is 2 feet tall while the kid is 1 foot tall, that's not the same thing. But even though it does reduce to a 2 to 1 ratio. And now, regarding the restricted values, okay, again, the denominator cannot be equal to 0. And if this trinomial cannot be 0, then neither can its factors. And so we have m minus 4 cannot be 0, and m plus 3 cannot be 0. Okay, so if m minus 4 cannot be 0, okay, we have that m cannot be 4, and m plus 3. If that cannot be 0, we have that m cannot be negative 3. Okay, and let me mention, okay, so the restricted values, okay, the restriction comes not what we have regarding the simplified version, but what we have originally. So in other words, the restricted values will both be 4 and negative 3. So on the basis of the original setup, 4 is baked in as a value that m cannot be, and the cancellation of m minus 4 does not undo the restriction. Okay, so you have restricted. Okay, so you have m cannot be 4, and we have the m cannot be negative 3. Now, in looking at what we have with 65, okay, so we're looking at adding fractions together. And so we got unlike denominators at the start. So we have 7 over 20x, and we have plus 2 over 15x to the fourth. Okay, and just kind of carrying out what we have. This is just one approach. Now we're looking at, say, determining the least common denominator. Okay, and we're going to convert both of these fractions in terms of the least common denominator, since we're not working with an equation. So we have with our numbers, okay, so we got 20 and 15. Now 20, if I display in terms of prime factorization, so 20, okay, you think of two numbers that go into 20. You can have 4 times 5 or 2 times 10. Now 2 is a prime number, meaning that the only positive whole numbers that go into 2 will be 1 and the number 2 itself. Now for 10, you have not just 1 and 10, but you also have 2 and 5. So 20 will factor out to 2 from the first 2, and then you have the next 2 from 10, and you have times 5. And for 15, 15 will factor out to 3 times 5. And we have with the variable factor. Okay, so you have the variable at x. Now for the least common denominator. For least common denominator. In fact, let me give just mention this too. Okay, so you have with your prime numbers or prime factors. Okay, so we got 2, 3, and 5. And for the least common denominator, okay, so we have with 2 does not appear at all from 15, but it does appear twice from factoring 20. Okay, so you have a couple of 2's, and we have with the number 3, this comes only from 15. And 5, it appears at most once from the factorizations involved. And we have with the variable factor, okay, so you have x and x to the fourth, so I'm going to go with the higher or highest degree representation. So least common denominator, okay, have 4, 2 times 2 is 4, times 3 is 12, times 5 is 60. And we have times x to the fourth. So looking at combining these ratios together. So I'm going to adjust both of these denominators to where we're going to have the least common denominator. Okay, so for 7 over 20x, now 20 will go into 60 3 times, and x will go into x to the fourth, x cubed times. So multiplying by 1 in the form of 3x cubed over itself. Now, for 2 over 15x to the fourth, okay, now we already have x to the fourth present. So we're going to multiply by 1 in the form of the number of times that 15 will go into 60 divided by itself. And so 15 will go into 60 4 times. So the second ratio is multiplied by 1 in the form of 4 over itself. So we have, upon multiplying and combining, so you got 20x, 3x cubed will multiply out to the same thing as what we would have with multiplying 15x to the fourth by 4. So we have 20 times 3 is 60, 15 times 4 is 60, and x times x cubed is already at x to the fourth. And so we have with the numerators, so we have 7 times 3x cubed. So we would have 21x cubed over 60x to the fourth, and you have plus 8 over 60x to the fourth. And it's by then you can go ahead and consolidate, and we will have the combined fraction where we have 21x cubed plus 8 all over 60 times x to the fourth. Now, in the case of 67, okay, this time we have three fractions, and here, okay, this one is a bit laid out. We have different denominators, okay, in the variable x. Here we have 4 over x squared. Then we have plus 3 over x plus 3. Then we have minus 2 over x. Now for what we have for the least common denominator, okay, now we have standalone variable terms with x and x squared. And so between the two, least common denominator, you're going to be stressing the higher degree in x, just like earlier, least common denominator, okay, you're looking at the higher order in x, and so that one went to x to the fourth. Here, with the standalone variable terms in x, we have x squared, and then we have the binomial x plus 3. So least common denominator, okay, we have it x squared times the quantity of x plus 3. So taking what we have among the ratios, so we've got 4 over x squared, and if I multiply by 1, okay, so you have x squared will go into x squared already, but we still have x plus 3 left over. So you have multiplying by 1 in the form of x plus 3 over itself. Then we have with the next ratio, so 3 over x plus 3. Now we have the x plus 3 factor, but missing we have x squared. Okay, now you got x squared but missing x plus 3 here. And you have x plus 3 but missing x squared with the second ratio. Now, for the last fraction, okay, this is perhaps the trickiest of the bunch, because what's happening here, we have x, and I don't have all of x squared, and I definitely don't have x plus 3. So you think of it kind of like maybe diluting to some extent, like x going to x squared x times. And you also have x plus 3 left over. So this last ratio will be multiplied by 1 in the form of x over x plus 3 all over itself. And we're going to have in the formation, if you notice, for all denominators, you have x squared x plus 3, x squared x plus 3, x times x is x squared, and we still have all over x plus 3. And for the numerators, okay, so you have 4 times the quantity of x plus 3, and we have 3 times x squared, and we've got bringing down the subtraction, we have minus 2 times x times the quantity of x plus 3. Okay, so we have 4 all over x plus 3. So this will form 4x plus 12. And we have plus 3x squared. And we have minus 2x squared. And negative 2x over 3 is going to be a minus 6x. Okay, and so just in the follow through. Okay, now you can put the terms in most any order. What I'm going to do in the final result, I'm just going to put the numerators, or I should say the numerator terms, in descending degree order. So if I take what I have in second order, so we got 3x squared minus 2x squared, so we have x squared And then we have 4x minus 6x, so we're going to have a negative 2x. Okay, so I've combined the x squared terms and the x terms, and left over is going to be the constant which we have in 12. So we have x squared minus 2x plus 12, and we have all over x squared times the quantity of x plus 3. Quite a bit of work in this one. Now, in the crossover, now working with number 76, now we've got fractions involved, and there's going to be a least common denominator to work with, but it'll be in the capacity of not converting the fractions in terms of least common denominator, but it will be where we're going to get rid of denominators through use of the least common denominator. And the reason I'm doing it for this problem is that we now have an equation, and we're looking at solving for the variable m. So we have m plus 2 over 3, and we have minus m minus 4 over 4, is equal to m plus 1 over 6, and we have minus 1. Okay, and just kind of give you kind of a preview. Yeah, this one we can get to least common denominator rather quickly. No letters involved. So you got 3 is already a prime number, and 4 is going to be 2 times 2, and 6 is going to be 2 times 3. So you got with your primes. Okay, so you have with the numbers 2 and 3. And so we have with the least common denominator. Okay, so you have with 2, it appears once from 6, but it appears twice from 4. And from 3, it appears once from 3 and also from 6. So we got 2 times 2 times 3, which is going to be 12. So 12 is going to be the least common denominator. And if I look at just clearing out the denominators, and the reason for this is that we have an equation as indicated by the equal sign. So we have, for multiplying, okay, so you have 12 times m plus 2 over 3. And we can go ahead and bring down the subtraction, and we have minus 12. And times the quantity of m minus 4 over 4. And we have equal to 12 times the quantity of m plus 1 over 6. We have minus 12 times 1. Right, so just taking what we have here, if we were to operate along the lines of cross multiplying, so we have 3 will go into 12 4 times. And then 4 is going to go into 12 3 times. And 6 will go into 12 2 times. And we're going to have in the rewrite, so we've got 4 times the quantity of m plus 2. Now we've got the subtraction to bring down, and we've got 3. We have times the quantity of m minus 4. And we have is equal to, and again, so 6 will go into 12 2 times, and to the right, so we have 2 times, okay, the quantity of m plus 1. Again, we have minus 12 times 1, so we have minus 12. And we have with the distribution, okay, so you have 4m plus 8, negative 3 over the quantity of m minus 4, so we have minus 3m plus 12. And for the distributing to the right, okay, so you have 2m plus 2 minus 12. And gathering, okay, the like terms, 4m minus 3m becomes m. 8 plus 12 is going to be 20. And to the right, I'm going to have 2m, and 2 minus 12 is going to be negative 10. And so, now normally I would like to have the variable I'm solving for on the left-hand side of the equation. But looking at how things are shaping up, okay, I have the smaller variable term on the left, and just to kind of putting any operations with negative numbers a bit more on hold. If I were to take the smaller variable term out, so we have 20 is equal to, and we have 2m minus m becomes m minus 10. And so for the isolated variable, I can just sort of step away from having to multiply or divide by a negative. Okay, and so we have 20 is equal to m minus 10. And so we have, for isolating m, okay, so just add 10 to both sides. And we have that 30 is equal to m. And equivalently, okay, so we have for the solution in m, okay, we have equal to 30. Ignore this. Yes, so what you would do, yeah, because what you're going to do in the case of the 12, it's going to be, okay, like before, if I had, in other words, if I had like if I didn't have the equal sign, I had like adding everything together, I would have had like so many twelfths minus so many twelfths, and say plus or minus so many twelfths, and then like minus 1, that would be converted to like negative 12 twelfths. If the only thing I could do was just to combine the fractions. So with the equation, it's like 12, it's just for the purpose of clearing out the fractions and just having like integer coefficients throughout for m. Yeah, and so yeah, so that one, and I know what you mean. It's like I don't have any expression in m in the denominator, like avoiding a 0 at the bottom, because these were non-zero to begin with, 3, 4, and 6. So there were no restricted values. In other words, because m was at the top, m could be 0, could be a negative, could be a positive. And with the nature of the equation being a conditional, where both sides will end up equaling each other, we had the unique value, okay, to be at 30. All right, and we have in the crossover for quadratics. And we have for number 80, okay. And this one can technically be solved in different ways. Okay, we have like 3y squared minus 4y is equal to 8 minus 6y. Okay, so you have a quadratic equation, and we don't have this one in standard form yet. And let's say that we have the highest degree term to be 3y squared. And what I'm going to do here, and because 3y squared is on the left, I'm going to set the right hand side equal to 0. So I'm going to move the 8 and the 6y over. So you have 3y squared, negative 4y plus 6y. Okay, we have a positive 2y. And we have minus 8 is equal to 0. And I'll mention, so for 3y squared plus 2y minus 8 is equal to 0. Okay, now 3y squared plus 2y minus 8, okay, that expression can be factored. If you factor, now the easy part is from 3y squared, okay, because 3y squared goes to 3y and y. And you can do stuff like factoring by grouping, or you can also use trial and error. Okay, so if you have like, if I have something like, so I want the sum of the terms to be, the outside and inside products to be positive 2y. So if I think of something like 3y minus 1, y plus 8, now I would have 3y squared. But if you notice, okay, we have positive 24y minus y, so you have plus 23y minus 8. But that's not going to be it. And if I have something like 3y minus 2, and I have times the quantity of y plus 4, okay, so adding a little bit less and taking away just a little bit more, so you got 3y squared. And you got 3y times 4, okay, so that'll be 12y minus 2y, so you have a plus 10y minus 8. And I still don't have the plus 2y. And 3 will not go into 8, but 4 will. So if I go with 3y minus 4 and y plus 2, okay, so I got 3y times y is 3y squared. And we got plus 6y minus 4y. Okay, so this will come out to positive 2y minus 8. Okay, so the combination that will ensure that once you FOIL out where the outside and inside products will amount to 2y, we're going to have 3y minus 4 and y plus 2. And okay, so you can factor. Now, I will mention, now in another class, somebody did ask if you could use the quadratic formula on this one, where a is at 3, b is at 2, c is at negative 8, and the answer to that question is yes. It'll be more work in a way, but you can use the quadratic formula and come out to the same results. And now for the results, we got these factors, and taking what we have with the zero product property. So if I set 3y minus 4 equal to 0, okay, so we have upon adding 4 to both sides, we have 3y is equal to 4, and we have upon dividing by 3, so we have that y is equal to 4/3. And as for y plus 2 is equal to 0, if we take 2 away from both sides, so we have that y is equal to negative 2. And so we have two results here, one a positive non-integer with a fraction of 4/3, and the other we have with a negative integer with minus 2. But again, you could use the quadratic formula, but you have to simplify the ratio ultimately. Okay, and now in the case of what we have sort of transitioning from rational to quadratic and to what we have with radical equations. And okay, we'll look at 86. First of all, 86 has just a single radical term. Whereupon we have the square root of 51 minus 14x. Okay, we have followed by the addition of 4 is equal to x minus 2. And we're trying to find out if there is a solution for x, okay, where both sides will end up in agreement. Okay, so I have a single radical term with the square root of 51 minus 14x, and the plus 4, I can just move that to undo the addition and thus isolate the square root of 51 minus 14x. So we have the square root of 51 minus 14x. And we have x minus 2 minus 4, so we have x minus 6. Now freeing up 51 minus 14x from the radical. So again, to eliminate the presence of square roots, okay, so I would just square. And squaring both sides, left hand side, okay, this will become 51 minus 14x. And for the square of x minus 6, again, so you just have x minus 6 times itself. The reason I'm saying this is that I've seen so many times that, many will remember to square the x and the negative 6 and forget that there is a tertiary term, that is a middle term. So we have x squared, and we have negative 6x and another negative 6x, so this will be minus 12x. We have plus 36. Okay, so you have the formation of a quadratic equation, and looking at gradually converting what we have here into a quadratic equation that is in standard form. So I have the x squared term on the right, so I can adjust to where the left hand side is going to be equal to 0. So I can take away 51 and also undo the subtraction of 14x by adding 14x. So here we're going to have that 0 is equal to x squared. Negative 12x plus 14x is going to be a positive 2x. And 36 minus 51, so this will be a negative 15. And so I'm just going to switch the sides here, have the trinomial on the left and 0 on the right. Kind of go from b is equal to a is equal to b arrangement. And if we look at factoring, so it looks like we'll have the quantity of x plus 5 times that of x minus 3 is equal to 0. And we'll have a couple of apparent solutions. Okay, so if I set x plus 5 equal to 0, then we'll have that x is equal to negative 5. And if I have x minus 3 equal to 0, we're going to have an apparent solution with 3. And now, it might be that both are going to be solutions, or it might be that one is going to be a solution, or it might be that neither one will be a solution. So if I check the values for x that are proposed, so if I go and check x equal to negative 5, if x is equal to negative 5, okay, now plug in negative 5 into x. Negative 14 times negative 5 is positive 70, and 51 plus 70 is going to be a 121. So I have the square root of 121 plus 4 is equal to, now for x minus 2, I have negative 5 minus 2. Negative 5 minus 2 is going to be negative 7. And now for the square root of 121, again, the square root of an expression cannot reduce to a negative constant. So the square root of 121 is 11 only. So we're going to have the left-hand side to be 11 plus 4. And 11 plus 4 is 15. And both values, the one we have to the left and the one we have to the right, are said to equal each other when in fact they are not. So trying to say that x is equal to negative 5 is trying to say that 15 is equal to negative 7. So negative 5 does not check out. And if we were to check x equal to 3, so you have 14 times 3 is 42. 51 minus 42. Okay, this will become the square root of 9. And here, followed by the addition of 4. X minus 2 becomes 3 minus 2. Now the square root of 9 becomes 3. Plus 4. 3 minus 2 is 1. And we have another roadblock here. 3 plus 4 is 7. And we're trying to say that 7 is equal to 1, so this is also false. And this is the trouble spot, and this is where the principal square root rule kind of overrides, okay, the potential for there being a solution. Had the square root of 121 been allowed to be equal to negative 11, negative 11 plus 4 would have been negative 7. And likewise, if I could make the square root of 9 into a negative 3, guess what? Negative 3 plus 4 would be 1, and 1 would be equal to 1. So had it not been for the limitation with the principal square root rule, I would have had two solutions. But because of the principal square root rule and that an even root expression cannot reduce to a negative constant, it turns out that we have, instead of two solutions or one solution, we end up with no solution in the result. Okay, now just kind of backtracking for what we have in the case of number 85. And in this one, okay, so we're looking at solving for k. You have a couple of radical terms here, so you have the square root of k plus 7 minus, okay, the square root of 3 minus k is equal to 2. All right. So you got two radical terms, and an approach I can take is to isolate, let's say, the square root of k plus 7. And if I do this upon adding the square root of 3 minus k, so we have the square root of k plus 7 is equal to 2 plus the square root of 3 minus k. And so I can free up the k plus 7 from the radical upon squaring. So if I take both sides of the equation and raise to the second power, okay, so left-hand side, okay, we're going to have it k plus 7. And to the right, okay, so for the square of 2 plus the square root of 3 minus k. So again, we have 2 plus the square root of 3 minus k times itself. Okay, so for the first product, if you FOIL out, 2 times 2 is 4. Outside and inside products will each be 2 times the square root of 3 minus k and for the last product case, you're looking at the square root of 3 minus k times itself. Okay, and that will technically go to 3 minus k, but I just want to use the square notation at the moment. So right now we got 4. The radical terms are like, okay, so we got 2 plus 2, square root of 3 minus k. Okay, so that's going to be 4 times, okay, the square root of 3 minus k. And we have, with the square root of 3 minus k times itself, that's going to translate to 3 minus k. And combining, we have 4 plus 3 is 7. plus 4 times the square root of 3 minus k. And again, we have the minus k at the end. Okay, so just relaying what we have here to the right hand side of the equation. Okay, so just looking at isolating this radical remnant. Okay, so I can remove the 7. If you notice right away, you're going to have complete cancellation of the 7s. And I can move the k by adding. And so now, okay, so we're going to have k plus k becomes 2k. I have 2k is equal to 4 times the square root of 3 minus k. And now in terms of following through, you can go ahead and square both sides, or you could divide by 4, having a fraction like k over 2 is equal to the square root of 3 minus k, or you can at least go, since we have even coefficients, just to sort of simplify a little bit, you could divide also by 2. So you could either divide by 4 or divide by 2, or go ahead and square both sides in the follow through. I'm just going to divide by 2 to at least go from 2k to k itself. So I got k is equal to 2 times the square root of 3 minus k. And again, we still have squaring to do. So now we're going to have k squared is equal to 2 times the square root of 3 minus k squared. And upon doing so you have 2 squared is 4. Square root of 3 minus k squared is going to be 3 minus k. Okay, now we squared the terms, but to the right, the squaring does not automatically take care of the multiplication. You had that bit to follow through on. Okay, so 4 times 3 is 12, and 4 over negative k becomes minus 4k. And so just setting the equation in standard form, so that add 4k and also take away 12. So you have k squared plus 4k minus 12 is equal to 0. And we have with factoring, so we have k plus 6 and k minus 2. And setting each of the factors to 0. Okay, so if k plus 6 is equal to 0, we have an apparent solution with negative 6. And if we have that k minus 2 is equal to 0, we have another possible solution with 2. And so just looking at what we have and checking the apparent results. So if I check x, or I should say k, equal to negative 6. Okay, so you got negative 6 plus 7. So that's going to be the square root of 1. And you got minus. Okay, now 3 minus negative 6 translates to 3 plus 6. So we have the square root of 9. We have is equal to 2. Now the square root of 1 is 1. And we have the subtraction of the square root of 9. So you have 1 minus 3. And for what we have, 1 minus 3 becomes negative 2. So that is going to be false. So -6 falls short. Okay, so all hopes ride upon the value of 2. Okay, so playing again, you have 2 plus 7 is 9. It got minus. Okay, 3 minus 2 is 1. Square root of 9 becomes 3. Square root of 1 is 1. 3 minus 1 is 2. And 2 is equal to 2. Okay, so the value of k equals 2 turns out to be true. So we do have one solution. So again, -6 falls flat. But positive 2 does work out. So you have that k is equal to 2. Okay, and just some items to go ahead and be looking into. Again, so you have the section R8 homework due this evening. And again, along with the rest of the set, we have with the absolute value, go ahead and be looking into numbers 130 and 132. And again, test 1 will be made available Friday at 12 p.m. And again, it must be completed in one sitting where there's going to be a 90-minute time limit. And the deadline for completing will be Monday, February the 8th at 11:59 p.m. And if anybody has questions, I will stick around. Otherwise, we'll pick up next time tomorrow.